Okay, lesson 25 is solving for other variables in an equation. So up to now, we've always had a single variable in our equations. Usually it's x, but it could have been any of the other letters. So up to now, we've only had single variables in our equations. And we solved for x. But what if we have, how do we solve for x? Well, actually, we cannot solve for x as a single number. We can solve for x in terms of y. What does that mean? Well, let's go ahead and still solve for x, and that means we still want to put x on one side of the equal sign. So what we have to do is subtract a y from both sides. And so we have 2x equals 6 minus y. We still want to divide by 2. So we've solved for x, it's just we don't have a nice single number. We have a y in there. That's fine. Okay, here we just solved for x. What if we instead wanted to solve for y from that same equation? We have to subtract 2x now because we want y by itself. And this is our solution for y in terms of x. Okay, so why is it we cannot actually get a single value for x and a single value for y out of this equation? Well, I'm going to clean the slate and I will show you why. The little table here. So if we set x equal to 1, 2 times 1 is 2, plus what equals 6? Well, y would have to be equal to 4. And we could actually solve for y algebraically, but I made the equation simple enough, I think I can do it without it. So if x is 2, then 4 plus what equals 6? Well, y has to be 2. If x is 3, y has to be 0. If x is 4, y has to be a negative 2, right? Because 4 times 2 is 8. 8 plus a negative 2 gives you 6. So you see, these are all the different, and it goes on forever. That's why we cannot solve for x as a single number or y as a single number in this equation. So what can we do with this equation? Well, we can graph this equation. When we graph the equation, it will show us all of the values of x and y that work within the equation. Okay, I went ahead and imported a graph, but it's not looking too good here, but we'll try to work with it anyway. Typically, we work with two axes. We call this the x-axis, and this is the y-axis. What we're going to do is we're going to go ahead and plot this equation here on this graph. Well, how do we do that? Well, the first thing we need to do is solve for one of the variables, and typically we solve for y in terms of x. So let's go ahead and do that. Well, we just did it before, but I'll do it again. So y equals 6 minus 2x. Actually, I'm going to just turn that around a little bit. I didn't change the value any, I just switched these terms around. Okay, and to plot this, we could do what we've done here, make a table of x and y's values. I'm going to go ahead and draw in some numbers on the graph here. Okay, and let's plot some of these ordered pairs. And they're called ordered pairs because they are in order. X is always first, y is always second, and they come in pairs. So we'll plot x is 1, y is 4. So this is the x-axis. So here's 1, and y is 4, so it's going to go right there. So that's the first point. The second point is x is 2 and y is 2. Third point, y is 3. I'm sorry, x is 3, y is 0. Go ahead and move this down out of the way because I'm going to use this space here. And the last one is x is 4 and y is -2. So here's our -2. Okay, you see what's developing here. We've got a straight line going. I'm off a little bit there, and what this line represents is whatever it represents the x value for whatever y value you want to assign to it, or the opposite way around. It represents the y value for whatever x value you want to assign to it. And again, this line represents this equation. A couple very important points here about graphs and the linear equation. When you put the equation in this form, where y equals whatever value is attached to x and then the coefficient after that, this is called the y-axis intercept form. What that does for you is it's very easy. It tells you that is where the line intercepts or intersects the y-axis. And the other important thing is this value here, either positive or negative, and in this case it's negative, tells you that that is the slope of the line. The slope is rise over run. Rise over run. So basically, in this case, how much did it rise for every x unit value? For 3 x values, the y value came down from 6 to 0. So that's a negative slope. So the rise over run is -6 because it's going down. See, it's not going up, it's going down. The rise is going down 6 units for every 3 units of x. Or that's the slope. And that's our value there.